Section 6.2, Properties of Parallelograms. Alright, in this warm-up, I want you to find the value of the variables, then find the length of segment AD and the length of segment DC. You can pause the video here and do the warm-up, and then I will explain step by step how we do it. First, I notice that segment AB and segment AD are congruent. So I set those two expressions equal to each other. X equals 3x minus 4. Now I just isolate x in this equation to solve for it. So I'm going to subtract 3x from both sides. I get negative 2x equals negative 4. Divide both sides by negative 2. X equals 2. Because segment BC and segment DC are congruent, I'm going to set those expressions equal to each other. Y plus 1 equals 2y minus 5. Again, using inverse operations here to get y by itself. Subtract y from both sides. And I'm doing two steps at once here. I'm also going to add 5 to both sides in order to balance the equation. So I get y equals 6. So I've answered the first part of the question, find the value of the variables. Now I need to find the length of AD and DC. So I'm going to plug these values in to find the length of each. So if I plug 2 in for x for segment AD, I get AD equals 2. And if I plug 6 in for segment DC, in for y in segment DC, I get DC equals 7. So we have a definition here for a parallelogram. A quadrilateral with both pairs of opposite sides parallel. So you can see the figure, you can see parallelogram ABCD. You see AB is parallel to DC and AD is parallel to BC. Take a moment, pause the video, name all pairs of opposite sides, all pairs of opposite angles, and name all pairs of consecutive angles. These would be angles that are right next to each other. So here's what we have. Hopefully you had something similar when you paused the video and did this on your own. Alright, so we have a few theorems to get through in this section, and they're all around properties of parallelograms, so different things that are true about the parallelogram. The first one says that if a quadrilateral is a parallelogram, then opposite sides are congruent. So by definition, opposite sides are parallel, but by theorem 6.3 here, we learn that opposite sides are also congruent. So in this example, it says solve for x, then find the length of segment AD and the length of segment BC. So, as you can imagine, we just learned because opposite sides are congruent, we're going to set these expressions equal to each other. Again, isolating x, getting x by itself, in this case on the right side, and then we'll add 3, we get x equals 5. So now if we want to find AD and BC, we're just going to plug that value in and see what we get. Well, when we plug a 5 into each of those expressions, we find out that both sides are equal to 7. Our next property here says that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So angles that are next to each other are going to be supplementary. We have a multiple choice question. What is the measure of angle P in parallelogram PQRS? Okay, so I'm looking over here at this lamp. I see the parallelogram PQRS. I notice the angle S is 64 degrees. So I'm going to set up an equation like this. The measure of angle P plus the measure of angle S equals 180. Substitute 64 for measure of angle S. Subtract 64 from both sides, and I find out that the measure of angle P is 116. The next property says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So opposite angles, we go angles that are all the way across the parallelogram from one another. So in the example above in the theorem, angle A is congruent to angle C, angle B is congruent to angle D. We're asked to solve for x and y in this parallelogram here, assuming that this figure is a parallelogram. Well, before, in theorem 6.4, we learned that consecutive angles are supplementary. So 3y plus y equals 180. So 4y equals 180. If I divide both sides by 4, I find out that y is 45 degrees. Then I can solve for x. I know that y is equal to 3x because those are opposite angles. So if I substitute 45 in for y, I get 45 equals 3x. Divide both sides by 3, I get x equals 15. So I've answered the question. X equals 15, y equals 45. The next property says if a quadrilateral is a parallelogram, then its diagonals bisect each other. Let's remember what the word bisect means. All right, we've talked about it a lot. Bisect means to cut in half. So in this case, the diagonals of a parallelogram are cutting each other in half. So if you look at the figure above in the theorem, parallelogram ABCD, you can see that segment BE and ED are congruent, as well as segment AE and EC. Those two are congruent. Here it says set up a system to find missing lengths of the diagonals of the parallelogram. Well, when I look at the diagonals, I notice that I have different variables. I have x and y. So I need to write two equations with those variables, x and y, that are true. I know that x equals y plus 2, and I know that y plus 10 equals 2x minus 8. So there's my system. How am I going to solve this system of equations? We know a few different ways to solve systems: graphing, substitution, and elimination. The method that comes to mind here is substitution because x is by itself in the first equation. So I'm going to take this expression y plus 2, and since it's equal to x, I'm going to plug that in for x in the second equation. So when I plug that in using parentheses, it looks like this. Y plus 10 equals 2 times what used to be x is now y plus 2 minus 8. I need to distribute. I get that. Y plus 10 equals 2y plus 4 minus 8. Combine like terms. Y plus 10 equals 2y minus 4. Subtract y from both sides. Get 10 equals y minus 4. Last step, add 4 to both sides. So y equals 14. Now I can solve for x. Plug 14 in for y into that first equation. 14 plus 2 is 16, so x is 16. Alright, it says set up a system to find the missing lengths of the diagonals. So I need to find the length of ln and the length of km. Well, if half the length of ln is x, because notice segment LP is x is 16, so if I double that, 16 times 2 would give me 32 for segment LN. Alright, and then I would do the same thing by plugging in a value for y. My value for y was 14, so 14 plus 10, I'm looking at segment KP, is 24. Again, double that to find the length of km, so km equals 48. Alright, here's our last property. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments at every transversal. So take a minute, just look at that figure. You see you have 3 parallel lines, you have a couple transversals. The segments that run between the parallel lines on the transversal are going to be congruent. Alright, so if you look at our example, it says what are ED and FD in the figure at the right? Well, I can see that CB is 8, BA is 8, FE is 12, ED should be congruent to FE, so ED should also be 12. And then if I'm finding FD, that should be what? 12 plus 12 is 24. Alright, so let's kind of go over what we've talked about in terms of the different properties of parallelograms. First, opposite sides of a parallelogram are, think about it, correct, congruent. Alright. Number 2, opposite angles of a parallelogram are congruent. Yep. Consecutive angles of a parallelogram are, give you a hint, it's not congruent. Supplementary. Diagonals of a parallelogram bisect each other. And then lastly, when 3 or more parallel lines are cut by a transversal, they cut off blank segments on every transversal. Think about it for a second. Congruent. Your homework tonight is on mathexcelforschool.com. Again, not due till Sunday at midnight.